I'm going to go ahead and make the video for section 9. It's a little more of an algebraic section than section 8. 8's a little more, I guess, graphical in nature. I kind of like to be there for that. So we'll do section 8 tomorrow. Section 9 deals with absolute value, mainly at solving absolute value inequalities. That's kind of the big thing with this chapter, is solving inequalities algebraically. Here's the algebraic definition for the absolute value. You may or may not have seen it before, but it should tie into your intuition. The definition says the absolute value of x is just x whenever x is positive or 0. So it's basically saying just leave it alone. If this number in here is positive, we'll just leave it alone. But if x is less than 0, so whatever number is here is less than 0, we're going to do the opposite of it. So if this were -5, we'd do the opposite of -5, kicks back out 5, and then that's kind of how you think about absolute value. You always get a positive number. So a graph of the absolute value function, we'll do the positive part first, it's just y equals x whenever x is positive, and you get that line with slope 1, y-intercept 0. And it's opposite x whenever x is less than 0, so it's just kind of the mirror image over the y-axis. And that's your graph of absolute value x. Well, we want to do inequalities with the absolute value. So now what would it mean for the absolute value to be, we'll start with less than some number a. So this is y equals a. Hopefully you can tell by the picture, or just kind of your intuition, that if y equals x is intercepting y equals a, this x value must be a, right there. And if y equals opposite x is intersecting y equals a, that's got to be opposite a. So it seems, and this is true, that the absolute value of x is less than a whenever writing this in kind of a one-dimensional graph is any time x is between opposite a and a. Your absolute value would be less than a. Similarly, we kind of go the other direction. If we wanted to know when the absolute value of x was greater than a, it'd just be everything that wasn't less than, so it's all this stuff out here rather than here. That'd be whenever x is greater than a, or x is less than opposite a. And then maybe your number line picture. Get that. There's an example there at the bottom that absolute values would be used for. Now, you certainly don't need the absolute value to be able to solve that question. You can just kind of look at it intuitively and be able to answer it. But we can set up an absolute value inequality and solve that to be able to answer what it's asking us as well. A machine stamps out circular washers that are supposed to have a hole with diameter 80 millimeters. The absolute error can be no more than 3 millimeters. So that's just saying you get a little 3 millimeters error to the bigger to the small of 80 millimeters. Write an absolute value inequality that D must satisfy. So when I'm writing this inequality, I'm thinking to myself, well, however far I am from 80, it has to be less than or equal to 3. So there's where your absolute value can come in. D is my distance of the diameter. Its difference from 80 has to be less than or equal to 3 units. Otherwise, we got to recalibrate the machine. So D's difference from 80 has to be less than or equal to 3, otherwise we got to start it over. Algebraically, how do we solve this definition? You probably solved these before, but I'm going to show you the way I teach them. I don't know whether that's the same way that your other teachers have or not, but I like to use the definition because I don't have to tinker around with flipping signs or anything like that. I'm just going to set it up straight up from the definition, so I'm going to think if my number inside is positive, I'm going to leave it alone. So I don't know whether this number is positive or negative, so I'm going to pretend it's positive and solve this inequality. And this is I'm halfway there now. I know D must be less than or equal to 83. That was probably the obvious one. The second part of that inequality is just using the other half of the definition. I don't know whether this is positive or negative. I assumed it was positive here, solved. So again, I'm going to pretend that it's negative to use this case. And if this number were negative, D minus 80, I'd do the opposite of it according to the definition. So I'll just do the opposite of it. Still setting it up with the same inequality. I'm just taking the opposite of what's in here. And I'll solve this, and it should get me the other half of my inequality. Dividing by -1 flips your inequality. D is greater than or equal to 77. So D is greater than or equal to 77 and less than or equal to 83. And that hopefully was your intuitive answer as well. To keep it within 3 units of 80, it must have been from 77 to 83. Alright, on the back side, we got a couple interpretations of the absolute value in terms of distance. One problem in the middle that you just use for your homework, and then 2 inequalities at the bottom that we can solve. So here we're just going to interpret what these mean. When I look at this, I see x, it must be within, or I guess in this case, it's got to be greater than 3 units from 7. So the numbers that satisfy this inequality are more than 3 units from 7. So there's a few ways I can say it. One way is x's distance from 7 is greater than 3. And if I think about that, then I'd obviously be 10 or more. I guess it'd be more than 10 or less than -4. And if you solve that inequality, that's what you get. Similarly here, x's distance from 3 must be less than 9. Or in other words, x is within 9 units from 3. In the middle there, you got a graph, and it's wondering what, I guess, m would be if we had a congruent graph, just maybe shifted somewhere else in space. And if you'd done section 8, this would probably be a little easier for you, but it's still not too bad. If I thought about factoring on the inside here, it's pretty clear. You could see you could factor out a 4. And because 4 is positive, it's not really affecting the sign of whatever this quantity is. If it was If it was negative, I'd maybe have to think a little bit more. But the x is the only thing affecting whether that expression is positive or negative. That 4 is not doing anything as far as the sign. So I could bring the 4 out if I wanted to and say it's 2 times the absolute value of x plus 2 plus 3. And the answer to your question there is 2, because every other absolute value function with a coefficient of 2 out front and no coefficient of x here is going to look all exactly the same. It's just going to be shifted somewhere else in space. Then if I wanted to find the vertex of this, again, if we had done yesterday's section, this would probably be a little easier for you, but you could always plot points to find the vertex. In section 8, we talk about horizontal shifts, vertical shifts from a parent function. The parent function is obviously absolute value x, and this is a shift of 2 to the left, and I guess it'd be 3, down? I should say minus. So the vertex of this equation would be at -2, -3. Feel free to graph it. It's no big deal. We'll talk about it more tomorrow. There at the bottom are 2 inequalities. We're going to solve them the same way we solved that washer problem on the front. Your first one is absolute value of 2x minus 10 is less than or equal to 3x. And second one is 7 minus 4x is greater than or equal to 3. This one's a little trickier because we got this x over here, so we'll pay attention to what kind of solutions we get when we get there. So, alright, I don't know whether this is positive or negative, so we'll pretend it's positive and solve this inequality. X is greater than or equal to -10. This is an and statement since we're less than or equal to, so I don't know whether this expression is positive or negative. We already considered the positive case. Let's consider the negative case. Opposite of 2x minus 10 is less than or equal to 3x. This will be a little bit more work to solve, but it's just a basic linear equation. So we end up with an interesting case here. We have x is greater than -10, and x is also greater than 2. And since it's an and, you're looking for the intersection of those, so it's really just everything greater than 2 for your final solution. You could try numbers less than -10, or I'm sorry, you could try numbers in here, but that's not actually going to work. It's going to satisfy one part of it, but not the other. This one's a little more typical of an inequality. You'll see you're just trying to figure out if the absolute value of some function is greater than some constant. We'll solve it the same way. 7 minus 4x is greater than or equal to 3. -4x is greater than or equal to -4. X is less than or equal to 1. Since it's greater than, this will be an or. Opposite of 7 minus 4x is greater than or equal to 3. So x is less than 1 or greater than 5 halves. On a number line, we look at something like this. Feel free to write your answer in inequality form. Draw the picture if you kind of want a visual of what values will work, but pretty much everything's going to work, just the ones from 1 to 2.5. are no good.